Hey everybody, it's Mr. Carr again. Today we're looking at 7-2 day one. Our main focus is going to be ellipses, but we're going to spend a little bit of time on circles real quick. So as a reminder, a circle is a set of all points that are equidistant from a center point. We show that distance using basically Pythagorean theorem, but it looks like this. So if we're centered at the origin, it's just x squared plus y squared equals r squared. Okay. And again, this is basically Pythagorean theorem. So x squared plus y squared equals r squared. Okay. If we move that center away from the origin, we're just going to model that with h and k like this. So x minus h, y minus k, and it's always opposite those values. So a very quick example of that. Let's scroll through here. Hold on a second. We'll just do this example right here, number 3. Okay. So this one, just to make sure we're clear, since it's a -3 plus 1, okay, my center is at the point 3, -1. So I'll start with that. So 1, 2, 3, and then -1 right here. My r squared is 25, so I square root that, so I get 5. So from that center point, we can go 1, 2, 3, 4, 5 to the right, 4, 5 up, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And there's my circle right there. Okay, so that's just a quick graph of that one. So we're going to move on from that because we want to focus more on our ellipses. So what is an ellipse? So an ellipse is the scenario where it's a collection of all points in which the sum of the distances from two fixed points, called the foci, is a constant. So in this diagram, my foci is F1 and F2 here. These are 2 points that exist inside the ellipse and always on what's called the major axis. We'll go over that a little bit more. But when you see this kind of like a circle stretched out, the major axis follows the longer section of it. So if I pick just randomly a point that's on the graph here, we'll call this one right here. Okay. If I figure out what the distance is there, I'll call it D1. And the distance there, okay, that's D2. Okay. The idea is that if I pick any other point, like for example, if I do this one, and I look at this distance and this distance, okay, I'll call it D3 and D4. Okay. So what happens in this scenario is that D1 plus D2 will always equal D3 plus D4. And again, it doesn't matter where we go. If I pick this point, I'm looking at these two distances, or it doesn't matter where the point is on the ellipse. It's always the distance to each foci added together will always be the same. Okay, so a little bit more on here. So we're looking at, again, our two foci. We got a centered H and K, just like with our circles. The major axis is always going to be marked with an A here. Okay, so this 1A is going towards the major axis there, and this is also a length of A. So if I look at the entire major axis, that's going to be 2A. Okay, excuse me. So the minor axis is going to be this marked with a B. So again, we always are going to do it as A is major, B is minor. So B is going to be the shorter version no matter what. Okay, so then, yeah, so A is always going to be greater than B. We can find it by using basically Pythagorean theorem again, but it's a modified version where it's this. C is the distance to the foci. So distance to this foci squared is equal to my major axis squared minus my minor axis squared. I should say semi. And the reason why is because we can create right triangles out of this. So for example, here is this length here, this length here. This length is basically the same as A. It's like sliding it out here. So I'm taking it and I'm kind of sliding it up a bit to make my hypotenuse. So that's why we have A, C, and then this is a length of B. So if I do that as A squared is equal to B squared plus C squared, that means my focus is going to be, if I subtract it over, A squared is equal A squared minus B squared is equal to C squared. So that's where this little formula is coming from. Okay. So a few other points here. Just looking at those. Again, A squared compared to B squared, we're always going to put it under the variable that has the major axis. So one thing to highlight here is that if I have x minus h squared like that, that means that my major axis is in the x direction. Here, if I put a squared under y squared, my major axis is going in the y direction then. Okay, so let's take a look at graphing now. So for our graphing purposes, first thing to notice is that since I have 9 underneath my x squared compared to a 4, 9 is bigger than that. So that means because of this section, it's going to stretch horizontally. Okay, so we need to graph this. We're going to start with the center. Writing that, so try that again, center on that one, which is going to be based on these two values. Just like the circle, they're going to go opposites. So -2, +1. Okay, then I'm going to need to find my vertices and co-vertices. Okay, my vertices are going to be along the major axis to the edges, and co-vertices are going to go the other way. Okay, and then also find the foci. So we'll start with this. The center is at -2, +1. So here's my center point. Okay. The length of my major axis is, so remember, this is basically saying that this is going to be a squared under here. So if a squared equals 9, that means a is equal to 3. This is the length of the semi-major axis. So from the center, I'm going to go 3 to the right and 3 to the left. So when I look at my values here, my x values are the what's changing, y stays the same. So -2 + 3 is going to give me 1, comma 1. And if I do -2 - 3, I'm going to get -5, comma 1. Okay, so those are my my major axis vertices. For my co-vertices, we're going to do the same thing with 4. This is b squared. So b squared is equal to 4, and then I square root that, so I get b is equal to 2. And I guess technically I should do plus or minus in both of these cases, because that is technically what I'm doing here. So graphically, I'm going to go from the center up to, down to. I have enough to graph my ellipse here. Okay, in terms of the actual points, I'm going to take the y value and change that. So x stays the same. I'm going to do 1 + 2 is 3. And I'm going to do 1 - 2, which is a -1. Okay, so last thing is to find the foci. Remember, this is c squared is equal to a squared minus b squared. So c squared is equal to 9 - 4, which is, when I solve that, is going to be the square root of both sides here, which is a plus or minus square root of 5. So what that means is the foci, which always will be on the major axis. From the x value, I'm taking -2 plus or minus √5, and then comma 1. So I'm going to estimate that a little bit here. So let me get rid of some of these extra little dots, because it's going to go on the major axis √5, which is a little bit more than 2. So it's going to go 1, 2, something like this. Here's my foci, focus 1 and focus 2. Okay, so that's my -2 plus or minus √5 there to get to those values. So let's do one more graphing, but it's not quite in our normal setup here. Okay, so for this one, we're going to do some completing the square to start this problem. So I'm going to rewrite this. I've got 4x squared, there we go, plus 24x plus y squared minus 10y minus 3 equals 0. Okay, or sorry, I'm going to change that. I'm going to put the 3 on the other side because I'm going to be doing completing the square here. For completing the square with x's, I'm going to first factor out a 4 out of here. So I'm going to have x squared plus 6x plus blank. Okay, remember doing the completing the square, I'm going to do 6 divided by 2 and then square that value. So that's going to be 3 squared, which is going to give me 9. Okay, do the same thing with y. So I'm going to y squared minus 10y plus blank. So I'm going to do -10 divided by 2 squared, which is -5 squared, which is going to give me 25. And that's equal to 3 plus my 2 blanks that I did earlier. 25 is easy. It's just that one right there. But this one is 4 times 9. So I'm going to add 36 over on this side to balance that out. Okay, block that out a little bit. Now the whole reason for completing the square is to factor this. So I'm going to have 4 times x plus 3 squared plus y minus 5 squared is equal to 64. In the way we had it set up, if I look at the previous one, ellipses will be always equal to 0. Or sorry, 1. So I always got to make it equal to 1. So in this scenario here, I'm going to divide everything here by 64. So that's going to give me x plus 3 squared over 4 over 64, which is going to simplify to 16. Y minus 5 squared over 64 equals 1. Now it looks like just like my previous one. I'm going to do the same thing I did before. First thing I'm going to notice, the a squared is underneath the 64 here, and the b squared is underneath the x. So it's going to stretch vertically. So my center is the point -3, +5 because of these two. So 1, 2, 3, 1, 2, 3, 4, 5. Okay. Oh, sorry, +5. So 1, 2, 3, 4, 5. My vertices. Okay. I'm going to take a squared is equal to 64. And I square root that. I get a plus or minus 8. It's stretching in the vertically. So I'm going to do the plus or minus 8 to the 5. So that means I'm going to have -3. And then 5 plus 8 is going to be 13. -3. 5 minus 8 is a -3. So I can go 1, 2, 3 here. And then I'm going to go off the chart. So that's, let's see here. This was 5, 6, 7, 8, 9, 10, 11, 12, 13. For my covertices, b squared is equal to 16. So I square root that. So b is equal to a plus or minus 4. So that's going to happen to the x direction. So I'm going to have -3 plus 4 is going to give me 1 and then 5. And I'm going to do -3 minus 4 is a -7, comma 5. So I can do that. That's 1, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7. Sorry, 1, 2, 3, 4, 5, 6, 7, and 5. So there's my graph. Still need to find the foci. So I'm going to do that with c squared is equal to 64 minus 16. So c squared is equal to, that's going to be 48. So I square root that. So c is equal to a plus or minus 4 root 3. So that means, again, we're going to go, when we do our foci, it's going to go with the major axis. So for this case here, my x value will stay the same. And then my y value is going to be 5 plus or minus 4 root 3. Okay, and that's it for ellipses. So we're just talking more about graphing them in this case, and we have to sometimes write the equation out and do some modifications. But for the most part, we're just looking at major versus minor axis, and then also finding the foci as well. All right, and that's it for today. Take care, everyone.